Okay, let's start the part 4 of the homework 2 hint. We refer as pallet logic. Um, Also, this part we usually refer as angel logic. Uh, we talk about why it's called angel logic later on. The pallet loading process, we trying to using a combiner, and a couple of things we need to set up. First is the so-called event trigger logic to generate pallet. So when we need the next pallet to arrive. Second, we're using an attribute called model entity serial number to keep track of each pallet uh, for each pallet logic and what is which pallet's number is on. We're also using a model state variable called current pallet to keep track of how many pallets we currently are generating already or generated already. Assuming in this process we only loading one pallet at a time. So these are the basic assumptions and the setup we will have. Initially we're going to have a pallet source. Using a source to generate pallet, and we're going to do this animation a little bit later, but I will do it offline, so don't occupy a lot of video time. And the source only generate pallets based on a specific event. Instead of using a inter-arrival time, this source of so-called source pallets only generate pallets based on a specific event. And this event would refer as a pallet needed. Whenever we need a pallet, we generate that pallet. At first, we define a user-defined event and call pallet needed, nothing else, and it's just called a pallet event, a pallet needed event. And also at the pallet source when they and every time a pallet is exiting the add-on, we will increment the current pallet number by 1. So the current pallet, every time we generate, we increase them by 1. And also, we assign that current pallet value attached to the pallet itself, called model entity serial number. So this is the trick we need to learn how to using a model level state variable, called current pallet, and also a model entity level state variable called serial number. Okay, so each pallet will get assigned to a serial number or pallet number. In kind of system or model level, I keep track of what is the current pallet number I'm on. And palletizer, we call it. We're using a combiner to combine the pallet with the TV, and the batch size is based on whatever homework assignment it is. So I'm using a property, so-called definition property, to decide what is the batch size is going to be. And also, when a pallet arrives, I will have one add-on process. When pallet exit, we will have another process. But I think this homework we may not need it right here. We need it somewhere else. So we'll talk about that in a few minutes. So just say if the pallet coming in, I need to do something. And what are we going to do? And this is what we call the angel logic. And when the pallet arrives to the parent nodes, and we need to do the following thing. This pallet is going to create a twin brother, and here we call it angel. And when pallet arrives to the palletizer, record the pallet number right now, and so duplicate itself. And this particular angel went to heaven, sleep for a certain amount of time. Here I have 45 minutes, in your homework maybe 8 hours. Then wake up, okay? And then wake up, come back to see if the current pallet processing is the same as has the same serial number as the angel has. So meaning the angel come back to the earth and then see if his twin brother actually still waiting to be pallet, fulfill the pallet. If this number, the serial number, are different, then we can dispose this angel, meaning his twin brother is actually move on to the destination. So we don't need this angel anymore. So we can basically dispose this angel. If they're the same, meaning the twin brother actually still waiting in the parent combiner queue, in the parent queue, to be waiting for more entity to come up. So we decided no longer need to wait. We need to move the pallet on. So therefore, we batch the current whatever entity we have in the member input buffer, along with some dummy entity. So we fulfill the entire pallet with a dummy entity. And after pallet is unloaded, then we split, check the presence of angel. If the pallets, actually the dummy entity, was batched with the whole pallet, then we dispose those angel. Otherwise, we can just went ahead to unload the pallet. It sounds a little bit fairy tale, but we see how we're going to manage to do that. So whenever the parents node has an incoming, so we call it palletizer incoming. This case, we create a duplication of the current pallet, and we delay for a limited amount of a so-called pallet dwell time, basically how long the pallets you want the angel went to sleep. If that's after that, it check if the member buffer still have something, and also current pallet, which is the state level, well, sorry, it's just the model level state variable equals to current angel serial number, meaning his twin part is still waiting in the queue. Then we create enough dummy entity and send it to the palletizer member input buffer. So we basically create enough dummy entities, fulfill the entire pallet, and get enough entity in the member buffer and member input buffer and send it forward so the palletizer can move on. Otherwise we go in this direction, and otherwise we transfer the angel into an angel trash input buffer and dispose the angel. So the add-on process is not that difficult. It's a little bit involved, but not that difficult. After we understand the process right here, we should be able to do that with this add-on process. The add-on process, again, is creating a duplication of the current pallet. We call that angel. The original pallet move on to the process, and the angel actually delay for a period of time, which is the waiting time we have. And after the waiting time of the pallet, they wake up and check if the current twin brother still in the parent queue. we call a parent input buffer queue. If it's not, we want to go ahead dispose the angel. If it's the twin bladder is still in waiting to be palletized, we create enough dummy entity so the pallet can move on. Then we send it to the member, which is a full, have a member input buffer, have enough entity to fulfill the pallet. Okay, the transfer block is the one we haven't introduced. Now we introduce, for now, a transfer queue is so from the one we created and send it to a station, and the station name is palletizer member input buffer station. We show you the program in a little bit, and also if our twin brother is already move on, then we just trash this angel entity we duplicated before. Here we're talking about the pallet question. What if there are no entity arrived in the past 8 hours, so the member input buffer is empty? Do we need a pallet? Should an empty pallet move on? So if nobody arrived, especially in the end of the simulation, you might have nobody coming in, not enough entity coming in within an 8-hour period. So should this empty pallet move on, or should it wait? If not, when it should move on? Do we need a pallet when there's no parts in the member input buffer? Member input buffer, which is the lower part, lower queue of the combiner, which is right here. Okay, this green line right here means the upper part is called parent input buffer, which is right here, and the member input buffer, which is the green line beneath it. Okay. Question is, when will we need a pallet? So how we're going to do when the pallet leaves the what we call the pallet unloading, we could file these so-called neat pallet event, so the source would generate another pallet to begin with. So let's start to talk about this. We come back to this presentation. We have the model from the previous example. The model actually has, after the post-inspection, we will need to go to the Pallet Logic. So we're going to make some room for the Pallet Logic for now. Okay, and we'll delete this particular path, and we're going to redirect them to a Pallet Logic. So we're adding a combiner right here. Adding a combiner, and we call it palletizer. We ask this to be a palletizer. Also, we're going to add a source to generate corresponding pallet, and call the source pallets. And also we adding a model entity and call pallet. And of course we're going to change this pallet into a, see if we have that. Okay, we input a pallet into the system, so this guys looks like a pallet. And also we're going to add some batch member queue from here. Okay, I just spent some time offline to make the queue, we call the batch queue, batch member queue, on top of the pallet, so we can visualize as palletizing process. Okay, and here all we have to do is linking these to here, a little bit over, so we can see that coming. Okay, so we palletize this, and also we need to set up a batch size. So we come to the property, set up a integer, we'll call the batch size. And the batch size is by default is 10. We can change that later on. Okay. Also, I would like to set up a waiting time. We call the pallet dwell time. Okay, the pallet dwell time basically is 8 hours for us, and we specify it is based on time, and it's 8 hours. Okay, so here is we set up these two properties. One we call the batch size, one we call the waiting time for the pallet. We call it dwell time, pallet dwell time. And here, the source, instead of generate model A, now I'm going to generate pallet. Okay, and instead of using an inter-arrival time, we're going to call it generate based on event. What type of event we're going to use? So here we can define the event in the definition, and we're going to create an event, and this event we call the pallet needed. So this is an event meaning I need a pallet. Okay, so it only generates an event based on the pallet was needed. Right here, pallet needed. Each time I'm going to generate one pallet. Okay, and initially, as our homework state, we have 5 pallets generated upon the simulation start. Okay, since we're only going to allow this, so batch size is number of pallets I'm going to generate. All right, and also for this combiner, I'm going to load in one pallet at a time. So I'm going to set the input buffer for the parents. It's going to be 1 only. Okay, so this pallet only have 1, and I'm going to prevent other pallet coming in from here. Instead of using a path, I'm going to change this link into a connector, so they will stay in the output buffer of the source instead of coming to the input buffer right here. All right, so this is the kind of trick we're going to use for the situation. And after the pallet is done, we're going to forward it into the destination, and we're going to unload the pallet. So here we're going to use so-called separator. So we're going to call unload pallet separator, giving some kind of path over here. Okay, I'm adding a sink for the palletizer to be unloaded. Okay, and then the original pallet goes to we can use connector right here. Goes to the sink. So this is the trash for the pallet, and rest of the parts transported by the pallet can go ahead to move on to the so they can move on to the packing station in that sense. So what we need to do is we need to add this portion into our process. First, we're going to set this to move on with the sequence, and also adding the input node into our sequence, member input node into our sequence. Go to the data right here. For that, before it goes to the packing, after post-assembly, we need to add a new row, basically the parents portion input node of the palletizer over here. Same thing for this guy. Before we go to the packing, we need to add that into the sequence. So that means after the post-inspection, the parts actually go to the input buffer. Sorry, it should be the member instead of the parent. Sorry. Let's go back to member input buffer, and this one too. Member input buffer for the input node for the. So after it's come out of the post-inspection, we should the parts should be going to the member input nodes of the palletizer. And also, now we need to determine when we need another pallets to be generated. And so every time we're going to start using the add-on process, this is fairly simple. So when a parent has an exit over here, now we're going to add a new process. Here we're going to be using a block called file. And we're going to file that event. This event call, I'm going to call this the pallet event. So I'm going to file that event, and the event name is being defined already, called need a pallet. So every time there is a part coming through the output node of this unload pallet, and we're going to generate a new pallet in that case. Okay, so let's see, everything is working. All right, now we kind of finish this, and we can see how the part's going. Okay, we can see how many parts coming through this direction already, and let's finish some of those more. What we need to do is now we need to tracking the pallet serial number and the we call the current pallet. So we need to go to the definitions, state variable to set up a, let's do an integer, and we call it current pallet. This is model level state variable, start with a 0. And also we need to go to model entity version to create similar things called serial number for the pallet. Okay, so and back into the model. Every time we generate a new pallet right here, we need to specify a new pallet, change the current model number. So after create, before the exit, we're going to using a assign block right here. Why don't we don't do that? Sorry. Let's just delete this process. Come back here, reset. What we do is instead of update the current product pallet number over the source, we're actually going to update them when they entering the palletizer. So the add-on process will be when the parent has an entering. That's what we do. When parent has an entering, we do assign block, two assign block. We can do it in one, but I'm just we could update current pallet number. Okay, and the second one we call this copy over to serial number, okay, of a model entity. So this part is fairly easy. We're going to do the current product number. Current pallet equals to current pallet plus 1. And the next will be copy the current pallet number to the model entity. Serial number equals to current pallet. Okay, so when we run this, we will see when we run this, we will see the pallet number goes on. But more to that, I want to be label each pallet what their serial number is. So why don't we do this, adding a status variable right here, and make a little bit pretty. And this guy, we're going to call this serial number. Serial number. And tell it a little bit so we can see them in that sense. Don't need to be too big. So you will see every time only one pallet being loaded at a time, the rest of a pallet waiting in the queue, output buffer queue for the source. And we will always have 4 of them lined up. Okay, every time we have parts coming through here, it will generate another one to replace of them. And this is one way to do that. We can also recycle the pallets back into the parents as well. So this is an alternative way to do the same thing. You see the actually entity coming up right here to be fulfilled on the pallet and then move on. And what we're trying to do is we can hypothetically adding a processing time for the unpalletizer. Let's do that. See if it's, the processing time. For example, I'm going to put it into 30 minutes so you will see what's going on. At least this is not needed. It's more of my illustration for make sure the process are working. So you will see what's going on. Okay, the pallet will be unloaded on this portion, and they start loading. The rest of the pallet is just waiting here. They don't have a serial number yet, and so we see how this will work. Okay, eventually. Okay. We can also see that after 601 pallets move on, and totally 3,000 parts being processed, and total 6,000 of 3,000 each of the TV will be processed. Okay, so 600 pallet being palletized, 601 is still waiting, but nobody coming in. So these are the basic logic we have so far. And next step is we're going to set up a process for the dwell time. Actually, we mentioned over the this process into our palletizing portion. So we start doing that over this process. Stop there, go here. Since the parent input, we already have defined the process. So this is the process we're going to be focusing on right now. Probably a little bit more involved. I want to quickly build this for you. We're going to, upon the arrival for the new pallet, we're going to create a new product called, actually it's a pallet. So this is so we're going to create Angel. Okay. And the original parts palette move on. The angel actually going to sleep for a period of time, and this time we call it happens to be palette dwell time. Okay, so delay for that period of time for the palette dwell time, and then I'm going to check after the angel wake up. Okay, so this portion I'm going to call it angel sleeping time for that regard, and then I'm going to make a decision if this angel twin brother is still right. Check twin brother still there. Okay, so what this part is basically we need to do is check if currently the current pallet let me do this real quick. The current pallet equals to the model entity serial number, which means the angel's serial number is equals to the current pallet we are working on. Also, and the palletizer's member input buffer has something in there. Member input buffer content number waiting is greater than or equals to 0. Meaning there's something in the input buffer waiting. Okay, if so, if that's the case, I'm going to create enough dummy entity. We're going to just copy the associate and create what type of entity type is the pallet, and the quantity will be actually the batch size minus whatever we have in the queue already. Palletizer member input buffer Okay, content, we know this before, and number weighting. So we're going to decide how many we're going to make up. Okay, so this is the amount I need to fulfill the pallet. I'm going to do -1 because the original is counted for 1. I'm just going to duplicate that many. Okay, then I'm going to transfer that as we said it before. We're going to transfer that to the member buffer, so member input buffer. So here what we have is going to do a transfer. Okay, I'm going to transfer to a station, and that station is unloading, pallet unloading, unload pallet, and should be input buffer. So I'm going to send it to sorry, not that. It should be palletizer member input buffer. So I'm going to send it to palletizer's input buffer, which is send it to down here. So here we create enough dummy entity from the parents, and then we send it to the buffer. Okay, and then we're going to be including the copy one all together into here. If this condition is not satisfied, which means the twin brother already gone, so we're going to create a dummy sink. We'll call it angel trash sink. So we're going to send those angel to the angel trash in that case. So over here, I'm going to do a transfer again and send that again to the station, and the input buffer for the, where is that? Hard to find actually. Angel trash input buffer. So I'm going to send it to that. So again, I'm going to color this a little bit differently. Make a color. This is going to be yellow. And the delay, I'm going to color a little bit differently for the green. And the decide block we have right here is trying to be deciding if the check and the to transfer no, we're going to call it different color as well. Okay, so you can see that with the color codes a little bit easier to, let's do this a little bit different color. Okay, so we create an angel to begin with, and delay for a period of time. Angel will be sleeping, and decide if the twin brother still exists. If it's not, and we're going to transfer this entirely to the angel trash sink. Otherwise, we're going to create enough copy dummy entity and move it to the member so that the palletizer can finish his pallet and move on. So, okay, now we're ready to test run this process, see if it works. I'm going to start running this and get it a little bit faster. So you can see the pallets move on. and so on and so forth. So I'm going to let it run to the end, double check. Okay, so this is the end of the run. We have both 3,000 TV finished, total 6,000, and we have 600 pallets to be palletized. We have 599 actually went to the angel trash, and so that means we have about one, which is the last one, actually has incomplete pallet and move on together. So this pretty much finish our Pallet Logic today. We show you how to using create an event and how to file event based on certain condition, which is coming back to the process. What we have is every time we have access from this parent nodes on the unload pallet portion, we generate another new pallets in replace of them. Every time the pallet can move on to the palletizer, it got assigned to a current pallet, okay, and copy this current pallet into his serial number. So the pallet, every single pallet be numbered when they're entering the palletizer parent input buffer. And then it got palletized based on a batch size. After a batch, move on to the unload and separate the pallet with the entity. The entity at the TV actually move on to the packing station, and the original pallet actually exit the system. So this is the basic structure to begin with. And also, in order to determine the dwell time, and we're going to follow this angel logic. The angel logic create an angel when the pallet arrives to the palletizer, recording the pallet number. Let the angel sleep for a certain amount of time, which is 8 hours, 4 hours. We're going to find out later on what is the optimal. See if the current pallets in the process is the same assigned as, so this portion we're going to check for is trim butter. If it's different, dispose the angel, we copy. If it's the same, meaning that the trim butter's pallet still waiting in the parent input buffer, we create enough angel, we call a dummy entity, to forward the pallet, okay? And then we batch the current contents in the member input buffer along with these dummy entity, dummy angel. And after the pallet is unloaded, then we will split it and then dispose the angel. So in order to do that, and we're going to start checking the process. You might have to, in the pallet portion, okay, in the packing, we need to add add-on process, okay, when they enter the system, or before they get processed. So here we're going to say packing enter. We're going to do a decide. Decide. And decide, what is the deciding do? And actually we're going to do is the entity is pallet. Because we could have a dummy pallet angels actually showing up. Then we just destroy them. Okay? And then if it's not entity, means they are either model A TV, model B TV, we'll let it go on. So we're going to destroy those dummy entity at the receiving end of the packing station, so we don't have any miscount. So this pretty much conclude what we have. A couple questions in the end I'm going to ask you is, so you need to figure this one out. What if there are no entity arrive at past 2 hours? So there is a pallet come in to be loaded, but there's nothing coming in the next 8 hours. What do? Should we an empty pallet to move on? Or if not, when should it be move on? Okay, so that's the question. Do we need a pallet when there's no parts in the member input buffer? So when we need a new pallet, okay? So these are the questions. The current version of the tutorial does not contain. And also, the final question is, as a homework stated, the pallet cannot move on after the unloading until all the parts on the pallet being processed. Okay, so this is pretty much the real manufacturing process, meaning if the pallets arrive to the destination and the packing, they're going to take it down one by one, to be processed until the last one leave the pallet to be processed. Then the pallet can be reused for the next palletizing. So this part I want you to think, there's not included in this part of the hint, and we leave some of those situations for you to figure it out. All right, I'm going to conclude this section of